So up to this point, we've called methods one at a time. And in an earlier example, we had a John car reference variable, and we set its make and year like this. We had two separate lines to do this, right? So let's discuss how you can chain these two method calls together like this. This is called method call chaining, and it's when you use a dot to concatenate a method call to the end of another method call. In this example, you can see the method call chain here, right? But how do we create methods to do it? It's not actually as difficult as you might think. In this code here, you can see that we have a method called setMake, right? So setMake is right here. And its return type is the same as the class that it belongs to. So if I build, you can see here that its class that it belongs to is car3, and you can see here that its return type is car3. And in the method, we return a reference to the calling object. And in this case, it's this. So I'm returning myself, right? So this allows us to, if it's returning a copy or a reference to itself, we can then call an additional method after the end of it. So we could call setMake over and over and over again using method call chaining if we wanted to. Or we could call setYear right after setMake because it's returning a copy of itself. So let's take a look at an example of this with car3 and its driver program. So here we have car3, and we have setMake and setYear, which we've kind of already looked at, and then a method called printIt, right? And here's our driver. It's a simple driver program. We create a car, and then we set its make, we set its year, and then we print it. All right, so let's compile them so you can see that it's not voodoo magic. All right. Oops. Helps if I hit the right button. Control 1. There we go. Control 1. All right, now we run it. All right, so here you can see it printed out its make and year. And that's exactly what it's supposed to do. Right? Print it. Print out make plus a comma and a space and a year. And if we look at our command window, that's exactly what it did. So you see, it's really not that complicated. So it's pretty simple to do, and it's not something that you have to do. This is an optional construct, so why bother with it? Well, that's because it can lead to cleaner code. Look at these two examples, and which one do you think is easier to read? Now, remember, the compiler doesn't care about white space. So all of this right here is purely for you and me to be able to see that, hey, we're initializing this car. We've got all these attributes and we're setting them, and it makes it really easy to see this way. And also remember that method call chaining only works on methods that don't need to return another value. So you're going to most often always see it with setters for sure, because you're not really expecting anything back, so you can program your object to return a copy of itself, so that way you can do this method call chaining. Also, another thing I want to point out is pay attention to the fact that there's no semicolons after all these, right? Because what's going to happen is when you run the compiler, it's just going to strip out all of this white space, and it's going to treat this like it's, you know, .setModel, so on and so forth, .setYear, right? And so it doesn't care about the white space. It will automatically delete all of that. So another powerful technique for adding some robustness to your classes is to use overloaded methods. All right, you're like, what are overloaded methods? Well, suppose you're writing software for an alarm system that uses a word, a number, maybe a combination of those two things, right? And to activate or deactivate the alarm, your program would first need to call a validation method that checks to see that the passed in word number combination is valid, right? So here are the headings for the methods that would implement that functionality, right? You would need to have a validate using word function. You would need to have a validate using number function. You would need to have a validate using a word then a number function, and then a validate using number then word, right? Word then number, or maybe you need word then number then word, or number word, you know, so on and so forth. You get the idea, right? You've got to have a lot of different functions that all do the same thing, but all have different names. And now you've got to try while you're programming this, you got to remember all those things. And see, it's really kind of annoying to do that. So this is where overloaded methods come into play. So how do we write these functions in a way that's not so difficult or annoying? Well, the better solution is to, as I said before, use overloaded methods. And this is where you have two or more methods with the same name, but different parameters. That is a different number of parameters or different types of parameters. And so here we could have, for the alarm system validation example, you could write 4 overloaded validate methods and call them like this. So instead of having validate word, validate number, validate so on and so forth, we just have a validate method. And that seems like it's a lot easier to use, to me anyway. So clearly only having to use one method name is much easier than remembering all the names for each possible combination. So let's take a look at another example. So here we have the height class, and we've got a couple different methods called set height. And here you can see we have some class attributes called height and units, and we can set the height with this constructor, and we pass in the actual height value, and we set the height variable, and we default it to centimeters. Then down here we have a different set height method. Notice it's the same name, same return type, but here we have double height and the string units. So it's a different method with a different number of parameters, but it has the same name. So this is what's called an overloaded method. And here we have our height driver where you can see it actually working. So let's go ahead and run it. And here is the results. So you can see we create a new height object, and we set the height to 72 inches, and we print it out, and then we set the height to 180, and we print it out. And you can see that when we print it, it automatically prints the, well, not automatically, but it prints the units, right? So you can see here when we didn't pass in a unit, it automatically defaulted to centimeters. So that is an example of how you can use overloaded methods, and I will tell you that they are quite handy, and you need to definitely be thinking about them when you're writing your applications. Now, suppose that you have overloaded methods and you're inside of one of the methods. So like the set height demo that we just went over. It's okay to call one of the other overloaded methods from the one that you're in. For example, you can replace the original one parameter set height method with the following implementation, which calls the 2 parameter set height method. So you see here, before we had it where it would automatically set the height to centimeters, but in this one we are calling the other set height method with the new parameters right here. So we're passing in the height and we're just putting that there, right? And then we're adding in this bit, which we're just saying, hey, we know it's centimeters because that's the default value, right? Also, note that you don't need to call the method with the this reference and the dot operator. Since we're inside of the class definition, the this is applied, or implied, excuse me. So you could write out this dot set height, right? Dot 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 dot. Okay, it's equivalent. All right, you don't need to do this. This dot, you can get rid of it. All right, constructors. Now, I showed you constructors in a couple other demos, but we're going to break them down a little bit more in this video. Up to this point, we've used mutators to assign values to the instance variables in newly instantiated objects. And this works okay, but it requires having and calling one mutator for each instance variable. As an alternative, you could use a single method to initialize all of the object's instance variables after you create that object. For example, you could define a single initCar method to initialize car objects and use it like this, like car ramrod. We're going to create an initCar method, and we're going to pass in all the attributes that we need to set. And this code fragment uses one statement to allocate space for a new object, and it uses another statement to initialize that object's instance variables. Since the instantiation and initialization of an object is so common, wouldn't it be nice if there was a way to write a single statement that could handle both of these operators? And this is where constructors come in. We can create a new constructor that will do the same thing for us in one line. So here we have car ramrod, and it's creating a new car with all of these attributes. Beautiful. So there's a couple things to keep in mind during our discussion of constructors. Number one is that a constructor lets you specify what happens to an object when it's instantiated with the keyword new. It's automatically called whenever an object is instantiated. And a constructor's name must be the same as the object's class name. And finally, we don't put a return type after the left or to the left of the constructor heading because constructors never return anything. All they do is they create something. That's it. Okay, so let's take a look at constructors with the car4 demo. So here we have car4, and you see we have these private attributes called make, year, and color. Here we have a constructor called, what do we say? It has to be the same thing, the same name as the class, right? Same name as the Java. So car4 Java, class car4, car4, and then its attributes, its parameters we're passing in, right? So this is how you declare a constructor. We're passing in these values, and we're assigning these variables to what we're passing in. That's it. Also, note that the constructor is going to come before anything else. That's a stylistic thing. You always put the constructors near the top. Another thing to be aware of is that you have to have a constructor with the same number of arguments as what you are calling, right? So if we tried calling this right here, if we got rid of the year, right, and just had volt and red, well, this isn't going to work. If we try compiling this, first let's compile our car class. Okay, that's good. And if we try compiling this, we're going to continue evaluation. Look at that. The actual and formal argument lists differ in length. Okay. So, how do we fix that? Well, there's two ways that we could fix that. We could create another constructor. Right? Let's copy this and boop. And we can get rid of the year. And what we would do here is we could just say, hey, you know what? We're going to set the year equal to 2010. Right? If we save this, compile it, and run it, you'll see that it compiled and ran just fine, right? It printed out the make. Okay, so that's one thing that you can do. Let me see if there's anything else I got to talk about. Oh, that's another good point. If you do not specify a constructor, if you don't give it any constructors, your class any constructors, the Java compiler will automatically create a constructor for you. It will automatically create the following equivalent, right? Whoops. Public car4 the Java compiler will automatically create this for you if you don't put in anything. Okay? So if you do put in something like these, then you will have to create your own empty constructor if you want one available to you. Okay? So, just to reiterate, anytime you instantiate an object with the keyword new, there must be a matching constructor. That is, the number and types of arguments in your constructor call must match the number and types of parameters in the defined constructor. And up to this point, even though we haven't created any constructors, how have we been able to create new objects? Well, that's because, like I said, the Java compiler will automatically create a default constructor for you. Okay? Yeah, that's it for constructors. Well, not quite. There's a couple more things we need to discuss. So let's take a look at this constructor business, the default constructor business, one more time. You can see here we have an employee class with just a one method, public void readme or read name, and it's going to ask you for your name and then it's going to print it out, right? And then we have the driver for it. So you can see here that we're creating a new employee even though we do not have a constructor defined for the employee class. And if we compile it, we can see that compiles fine. We run it. Get my command window over here. There we go. Name, Corey. Peachy Keen, right? It works just fine. All right, but if we look at this employee2 class, you can see here we are creating our own constructor, and where it takes a string argument and it sets its name equal to the string, right? And then it's going to print out the name, yada yada yada. So here's the driver for it. If we try compiling and running these, all right, compile it. If we try compiling it, look at that. Lo and behold, we get an issue. New employee 2, string, no arguments, reason, actual and formal arguments list differ in length. That's basically telling you, hey, I don't have a constructor that takes no arguments. So how do we fix it? Well, we add a constructor with no arguments. And we compile it. And we run it. And lo and behold, you see everything works peachy keen, jelly bean. Right? Alright. So, if you write your own constructor, you have to supply a default constructor if you expect to use it. The compiler will not do it for you automatically. So I kind of gave you a little hint of this already, but just like overloaded methods, we can overload constructors. And this occurs when there are two or more constructors with the same name and different parameters. And it works exactly like regular method overloading with one caveat. A call to an overloaded constructor from another overloaded constructor uses this syntax. So you use the keyword this, followed by parentheses, and then whatever arguments for the constructor that you want to call. And a call to another constructor may appear only in the constructor's definition, and it must appear at the very first statement in the constructor's definition. So you can see another example of this on the next slide. So here we have a very simple program to illustrate the call to this construct. So here you can see our driver where it's simply our main function. We have fraction A equals new fraction and it equals 3/4. And then fraction B is a new fraction and it's passed in just this 3. So we're like, that's not a very good fraction. All right, so let's take a look at the fraction class and see what's going on here. Right, so here we have a integer numerator and an integer denominator, okay, and then the private double quotient, right? And as we all know from elementary math, like 3rd, 4th grade, that's equal to the numerator divided by the denominator, right? So right here, we see the call to this in effect. We have public fraction int n, so we pass in a single number, and we're going to call its other constructor that has 2 parameters, and we're going to pass in a integer n and the number 1, and so then it's going to call this fraction right here. Now and you can see that this requires 2 integers, n and d, for numerator and denominator. Now notice that they're both ints, so if this was, say, a double and you tried calling this, it wouldn't work because the types don't match. But because this is an integer and it's passing in the appropriate arguments to this method and this constructor, then this is going to work. And so here you can have it see it setting the fraction to this numerator to n, the denominator to d, and it's running this block of code and setting it equal, or the quotient equal to the result. All right. So, and that's how that works. So let's go ahead and run it and take a look at it. We'll compile it, and we'll compile it, and we'll run it, and pull this over here. So there you can see that 3/4 equals 0.75, and 3 divided by 1 equals 3.0. So that's how you can make a call to this to run other constructors. Now, as a side note, you can add in additional information. You can do different things. Like, say we could add some code here, you know, do something, and what's going to happen is it's going to get to this constructor, it's going to jump down to this constructor, perform all of this work, return, and then execute the rest of the code. All right, and you can actually chain constructors one after the other, but this call right here has to be the first line in the code, or it's not going to work. The compiler will throw an error at you, right? So actually, let's take a look at that. Let's say int I equals 3, right? All right, we go ahead and try to compile it, and look at that right there. Call to this must be first statement in the constructor. So it tells you point blank what's wrong. So that's pretty convenient that you get clear and concise error statements, which always help when you're programming. So there you have it.